Welcome to all viewers, subscribers, watchers who are actually presenting in today's session. A warm welcome to IG Bits. We train, you will get an opportunity to learn. So we will continue our partial fraction session. Let's get started. I wish I would like to let you know that we have a YouTube channel, the channel name IG Bits. Feel free to log into YouTube and then subscribe the channel. Your support is very important and essential for us to sustain the channel information, keep updated, and then your helping hand will support us to build the more knowledge and then sharing across, right, all the people who are like us to actually get the access and then learn the unseen topics. Okay, and feel free to share the channel to the your circle so that we can extend our helping hand to the rest of the world. Thank you all for keep staying with us and then keep help expanding our channel data to rest of the world. So far we covered, based out of our last session, fractions, types of fractions, I mean proper fraction, improper fraction, mixed fraction, like fractions, unit fractions, and then we also talk about numerator, denominator, how that will get affected in the overall fraction, like a proper or improper differentiations and all, right? Fundamentally, when we talk about fractions, we should have to remember what is meant by rational fraction. Suppose we have a f of x and g of x are two polynomials, and a condition g of x is a non-zero polynomial. In that case, f of x by g of x is called as a rational fraction or a simple fraction. You agree? That's correct. So if we can take in any the example, let's say I'm writing down 5x plus 1 over x squared plus x minus 2. Okay, this is a rational fraction. This is the rational. First of all, these are two are the polynomials, and second thing, denominator is non-zero, right? This one is non-zero, and hence these are the rational fraction. Let's give one more example. X cube plus 2x plus 5 over x square minus 2 divided by 2. This is also a rational fraction because denominator is non-zero and then both are polynomials. Okay, so rational fraction, whenever you see like in a polynomial equation, you can easily notice and recognize a rational fraction means. And then once you have the rational fraction, then we can start defining a proper, improper fraction and irreducible polynomials, these concepts. Let's see them in the next slide. Let's see concept of proper fraction. As we discussed, a rational fraction f of x by g of x is called as a proper fraction with condition. What is that condition? If degree of f of x is less than the degree of g of x. Make a note, a degree of f of x is less than the degree of g of x, then that rational fraction is called as a proper fraction. Let me change my pen color. So what we are saying is, in this case, degree, isn't it? So you can take a previous example, 5x plus 1 divided by x squared plus x minus 2. What is this polynomial degree? 1, x power 1, is it? What is this polynomial degree? 2. This one is 2. So numerator value is 1, denominator value is 2. So proper fraction means degree of f of x is less. Agree? So this one is less, right? This one is greater. Hence, this is called a proper fraction. So you understand how to identify proper fraction and then improper fraction? Yeah, you can take in one more sum. X to the power of 4 over x cube plus x square plus 2. Some polynomials. So now you see degree of numerator polynomial value is 4 and degree of denominator polynomial, highest degree of denominator polynomial is 3. So which one is greater? 4 is greater, right? If the numerator is greater, okay, that means like if f of x is greater than g of x, then what do you call it as? Improper fraction. Okay, improper fraction. I think we talk about this thing also in simple terms. 1 by 4 is a proper fraction, whereas here 5 by 2 is improper fraction. This is not improper fraction, right? This one, because this is proper. Out of 4 parts you got 1. In this case 5 by 2, right? When you divide, what happens? This one whole number will get it, right? 2 plus 1 by 2, something like this. 2 whole parts plus half. That's what 5 by 2 meaning. So this is nothing but a mixed fraction and improper fraction. Clear? Let's move on to next topic. Reducible fraction. Let's define the reducible fraction now. A fraction that is reducible can be reduced by dividing both numerator and denominator by a common factor, right? So what we are trying to do here, let's say take any example, 120 divided by 90. This is a fraction. Okay, now this fraction can be reduced. Yes, it is reduced. How? By dividing with a common factor. Let's say 120, meaning 12 times 10. What about 90? 9 times 10. So there is a common factor 10. If you can divide with this common factor both numerator and denominator, what you will get it? 12 times 10 divided by 9 times 10. So you can strike off these two. So what it remains is 12 by 9. You can further divide it. Yes, we can, because 12 can be written as 3 times 4. 9 can be written as 3 times 3. So common factor is 3, and hence 4 by 3, 3 by 3. You can cross 3, 3. Then what is remains is 4 by 3. Will you be able to divide further? No, right? There is no common factor except 1 is only common factor. For 4, you see 4 1s are 4 or 2 2s are 4. For 3 what we have is like 3 1s are 3. So only common factor is only 1, and hence we can say any fraction, something that you are able to reduce further, is called a reducible fraction. Okay, let's look at next one. Now let's see irreducible fraction. How do you define? An irreducible fraction or a fraction in lowest term, a simplest form, or reduced fraction. If any fraction that is already reduced, you cannot reduce it further. Such a fraction is called as a irreducible fraction. The numerator and the denominator are the integers that have no other common divisor than the 1. Right? So what we seen in the previous example, if I have a fraction like a 4 divided by 3, only the common factor between the 4 and 3 is only 1, right? So you don't have anything more than that, and hence this is already a reduced fraction. It is already a reduced fraction. So you cannot reduce this further, and hence this is called irreducible fraction. Think about 3 by 7. What is the common factor we have? 3 1s are 3, 7 1s are 7. So only 1 is a common. Other than 1, we don't have any other common divisor, and hence this is also irreducible fraction. Okay. Similarly, how do you define irreducible polynomial? The definition is, a polynomial is said to be irreducible if it cannot be expressed as a product of two polynomials like a gx and h of x, such that the degree of each polynomial is less than the degree of f of x. So let me give an example for this. Let's say I have 2x plus 1. This is f of x. Can you write this as a product of two other polynomials like g of x into h of x? If you are able to express in these terms, then we can say it is a reducible polynomial. Let's say, for example, x square minus 1 can be written as x plus 1 times x minus 1. Correct? So degree of polynomials, these are the two polynomials, right? This is a g of x, let's say this is h of x. The degree of g of x is 1, degree of h of x is 1, which is lesser than the your f of x. That's the first rule. Second thing, you are able to express with two polynomials of lesser degree, isn't it? That means like x square minus 1 can be expressed as a product of two smaller polynomials, isn't it? So this what we can call it as a reducible polynomial. Is it? So but this case, if you see 2x plus 1, I don't think like I can write further because this is already a reduced fraction, a reduced polynomial. You can say, you can term as a reduced polynomial. So we cannot express it by other smaller polynomials because this is already reduced, right? So this is the difference between reducible polynomial versus irreducible polynomial. Based out of this concept, all our partial fractions can be resolved. Okay. Okay, let's move on to next subtopic. We have seen partial fraction for the numbers, right? But let's look at a definition for polynomial. A partial fraction is expressed as a sum of two or more proper fractions, wherein denominators are powers of irreducible polynomials. Then each proper fraction in the sum is called as a partial fraction. Okay, let me give a simple example. Let's say we have 2x plus 3 divided by x square minus 5x plus 6. So denominator polynomial x square minus 5x plus 6. If we can factorize these things, how do you represent? This is nothing but x minus 2 and x minus 3, right? So if you can rewrite this now, 2x plus 3 divided by x minus 2 x minus 3 can be rewritten, let's say for example, some value by x minus 2 plus some value b by x minus 3. If you look at these things, these are the irreducible polynomials, right? These are irreducible polynomials. Irreducible polynomials. So from the definition, this is satisfying condition. Both are expressed as a product, can be expressed as a two a simple fractions. Denominators are irreducible, and powers is also yes lesser degree than the the given polynomial, and hence these should be a proper fractions, and then summing of these proper fractions gives rise to your original fraction. When you are able to express a given fraction into a sum of two or more partial fractions, simple fractions, then these decomposition is known as a partial fractions. Clear? Our example is to decompose the given fraction into a partial fractions. We have a few methods to resolve a given fraction into partial fractions. Got the concept? This is good one. We will look at the few methods and then sample examples of those methods to understand the concept. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you all. We reached the end of the session today. We will see few more concepts in next session. Until then, have a good day. Bye bye.